Great. So, like Anupam was saying, we are the impulse manufacturing laboratory. And when we say impulse, when you hear impulse, you should think of something that's really sharp, but also very brief. So, the analogy I always like to use is like hammering a nail into the wood. So, if you think about that process, you impart a good amount of energy into the nail, but the time of contact is actually very brief. It's just like a split second, right? So when you take all that energy and concentrate all that energy into a short time, you can really make a sharp pulses of force doing that. And you can really drive the nail into the wood by doing that. Versus if you take that same amount of energy but spread it out in time, that is, if you try to push the nail into the wood, it's never going to go anywhere, right? So in the same way, by using impulses, we can work metals in ways that we couldn't do otherwise by slower means. How fast are we talking about, right? We're really talking about like, well, depending on what application, but suppose we say welding. In welding, we're looking for speeds on the scale of several hundreds of meters per second. For reference, speed of sound in air is 300 something meters per second. So we're looking at Mach 1 to Mach 3-ish kind of regime. And how can we make things go that fast? Well, one way is by explosives. One of the very few ways you could do it. So that's what people have been doing for decades. They use explosives to make things go fast. But here we don't use explosives. Instead, we use this innocuous piece of aluminum foil. And that's really what that is. It's aluminum foil. But what we do with it is, behind you there is this green machine. It's a capacitor bank. So a capacitor bank is like a storage vessel for electrical energy. So what it can do is it can charge up a certain amount of energy and let that all go at once. It's kind of like a rubber band. You charge it, and bam, you let go, right? A lot of that energy is released at once. So in the same way, this capacitor bank stores up electrical energy. So take that amount of energy, pass it through this aluminum foil in the form of a high current in something like 20 microseconds. So very sharp electrical impulse. And when we pass a current through a conductor, what happens? Resistance. Resistance causes it to, heat up, right? So, so just like a light bulb, it heats up. But if you put in a tremendous amount of energy in a very short time, it doesn't just heat up, it actually vaporizes. Not even melt, it vaporizes because there's so much energy. So when it goes from solid to vapor, that's a very drastic volume change in a very short time. So it creates a very sharp pulse of pressure around it, and that's what we use to push metals to make them go really fast. So this is something that we did with what I just talked about. These are all welded pieces of of metal. They're welded together. Typically, when we think about welding, we think about a lot of heat. But actually, we can do welding without a lot of heat, just by slapping them together really fast. On the scale of several hundreds of meters per second, we can make them weld just like that without putting in heat. Sounds like magic, but it works. You're holding the evidences in your hands. Something else we can do with that sharp impulse is we can cut metal without a whole lot of burr. Typically, if you do it slow, you have a sharp edge, right? That burr. But if you do it fast, you can feel it. There's hardly any burr there. We can also use that impulse to form sheet metals into a shape. So in this case, this could be a case for something. But anyways, we're trying to make a shape, right? In some cases, though, if you try to just press it into that shape slowly, it could start to shear and crack somewhere along the edges. But in some cases, not all cases, if you do it with an impulse, you can actually improve the formability to make it not shear.